Hello everyone, welcome back to my channel. So in this video we are going to learn about zeros of analytic function, and types of singularities. Okay, so if you are first time to my channel, please consider subscribing. Right, so first of all we read about zeros. Okay, zeros of analytic function. Zeros of analytic function. A zero of analytic function f of z is the value of z such that f of z is equal to 0. So all the values of z which satisfies the equation f of z is equal to 0 are said to be zeros of analytic function. So order of 0 of analytic function. Okay, so how to find the order of 0 of this? That is 0 of order 3, 0 of order 2. So how to find the order of this analytic function? So if f of z is an analytic function about z is equal to z0, and f of z0 is equal to 0, f dash of z0 is equal to 0, similarly f double dash of z0 is equal to 0, and so on up to f m minus 1 of z0 is equal to 0, and f m of z0 is not equal to 0. If m of z0 is not equal to 0, then z0 is said to be 0 of order m. So if you have a f of z is a analytic function about z is equal to z0, and you have the values f of z0 0, f dash of z0 0, f double dash of z0 is 0, and f m minus 1. That is, if you differentiate m minus 1 times and substitute z is equal to z0, also you will get z if you are getting 0, and f m of z0, that is, if you differentiate m times and if your value is not equal to 0, then z0 is said to be 0 of order m. Okay, in simple, so if you differentiate m times, so after m times, if your differentiation value, so fm of z0 is not equal to 0, then z0 is 0 of order m. So first differentiate m times, so after m times, if fm of z0 is not equal to 0, then z0 is 0 of order m. For example, if you take f of z is equal to z minus 4 whole square, okay, so z is equal to 4 is 0, yes or no? So the zeros are same. A zero of an analytic function f of z is the value of z such that f of z is equal to 0. So when you make f of z is equal to 0, that is z minus 4 whole square is equal to 0, so you'll get z is equal to 4 only. Z is equal to 4 is the 0. That means here z0 value is 4. Okay, so if you substitute f of z0 means 4, f of 4, if you substitute, what you'll get? 4 minus 4 whole square, which is equal to 0. Even if you find f dash of z is 2 into z minus 2, z square form, so 2z. So if you substitute 4, when you substitute 2 into z minus 4, even if you substitute z0 is equal to 4, so f a dash of z0 is f dash of 4, which is equal to 2 into 4 minus 4. 4 minus 4 is still 0, and f double dash of z, f double dash of z is 2z, and f double dash of z naught, that is f double dash of 4 is 8, which is not equal to 0. So after integrating it for 2 times, the integral value, so after differentiating it for 2 times, the value is not equal to 0. So after 2 times, here m value is 2, so after 2 times f2 of z naught, f double dash of z naught is not equal to 0. Therefore we can call z naught, that is 4, is 0 of order 2, 0 of order 2. Okay, this is the standard procedure to find the order of a 0. Okay, directly also we can say, so if you equate it to 0, so z minus 4 whole square is equal to 0, so z is equal to 4 comma 4, therefore z is equal to 4 is 0 of order 2, of order 2. So this is directly telling, and this is the standard procedure in order to find the 0 of an analytic, sorry, order of 0 of an analytic function. Okay, right. So next we'll discuss about types of singularities, types of singularities of analytic function. Okay, right. So types of singularities, there are 3 types of singularities. One is essential singularity, second is removable singularity, next third is pole. Okay, so this classification is based on Laurent series. This classification is based on the Laurent series principal part. That is, Laurent series of a function f of z is given by summation n is equal to 0 to infinity an into z minus z naught whole power n plus summation n is equal to 1 to infinity bn by z minus z naught whole power n. Okay, so this part is called as principal part, that is negative powers of z minus z naught. This part is called as principal part of, so we will discuss this very clearly when we discuss the concept of Laurent series. Okay, so until then just keep in mind the types of singularities. Okay, I'll explain you clearly. So this part is called as principal part, where you are containing so negative powers of z minus z naught, that is b1. So when you substitute 1, so it will be b1 by z minus z naught plus b2 by z minus z naught whole square plus b3 by z minus z naught whole cube plus so on. So if you take this to numerator, what will happen? So b1 into z minus z naught whole inverse plus b2 into z minus z naught whole to the power of minus 2 plus b3 into z minus z naught whole to the power of minus 3 plus so on. So it is negative powers of z minus z naught. Okay, so based on this value only, based on this principal part only, we are classifying this singularities into essential singularity, removable singularity and pole. Okay, so essential singularity, if the principal part contains infinite terms, about z is equal to z naught for function f of z, then the type of singularity z naught is essential singularity. Okay, suppose for example e power 1 by z about z is equal to 0. If you have e power 1 by z expansion is, so we know that e power x expansion is 1 plus x by 1 factorial plus x square by 2 factorial plus so on. So e power 1 by z in the place of x, now you have 1 by z. So 1 plus 1 by z by 1 factorial plus 1 by z square into 2 factorial plus 1 by z cube into 3 factorial plus so on. If you see here, so this is all negative powers. About z is equal to 0, so you can write this as z minus 0 whole square. Z square can be written as z minus 0 whole square. Z cube can be written as z minus 0 whole cube. So all these are negative powers, and there are infinite number of terms like this. That means the principal part, all these are negative powers. Negative powers means principal part. So principal part is containing infinite number of terms. Therefore z naught is called as essential singularity. So here z is equal to 0 is essential singularity. Essential singularity. Okay, so this is what essential singularity is. Next, removable singularity. If principal part is equal to 0, that is not present, if the principal part is not present, then such type of singularity is called as removable singularity. Removable singularity. Okay, so that type of singularity is called as removable singularity. Suppose if you take 1 minus cos z by z, 1 minus cos z by z. So what is cos z? Cos z is 1 minus z square by 2 plus z to the power of 4 by 4 minus z power 6 by 6 factorial plus so on. Okay, so this is the expansion of cos z. So 1 minus cos z, 1 minus cos z is 1 minus of 1 minus of 1 minus z square by 2 factorial, z square by 2 factorial, sorry, this is factorial, plus z to the power of 4 by 4 factorial minus z to the power of 6 by 6 factorial plus so on. So 1 minus 1 is 0, so you'll get z square by 2 factorial plus z to the power of 4 by 4 factorial plus z to the power of 6, sorry, this is minus z to the power of 4 by 4 factorial minus z power 6 by 6 factorial plus so on. So if you multiply, if you divide this by z, so 1 minus cos z divided by z is, so this is 1 by z multiplied by z square by 2 is z by 2. 1 by z multiplied by z to the power of 4 is z cube by 4 factorial. Z to the power of 6 multiplied by 1 by z is plus z to the power of 5 by 6 factorial plus so on. So if you observe here, you will get only positive powers here. Z, z cube, z to the power of 5. There is no negative powers like 1 by z like this. So here we have got negative values like this. 1 by z, 1 by z square, 1 by z cube. So you are not getting any negative powers. So principal part is going to be 0. If principal part is 0, then z is equal to 0 is said to be a removable singularity. Is said to be removable singularity. So for this function z is equal to 0 is removable singularity. For this function z is equal to 0 is essential singularity. Okay, so depending on the function, even for the same value of z naught, you will get one as essential singularity and the other as removable singularity. Understood? So this is the difference between essential singularity and removable singularity. So pole is, if you have the principal part is containing finite number of terms. Finite number of terms. Okay, so finite number of terms, then it is called as pole of order m. So if it contains finite number, so that finite number is m. If you think that total number of terms is m, then it is called as pole of order m. Pole of order m. Okay, so I'll take a question in when I'm explaining you the Lorentz series, and I will explain you the concept of pole also. Okay, there I will clearly explain you the concept of pole. Okay, so I hope you have got the difference between essential singularity and removable singularity. So in essential singularity, principal part contains infinite number of terms, that is negative powers are infinite in number, and removable singularity, principal part is 0. There is no negative powers of z naught, negative powers about z naught. Okay.